Hello everyone, happy holidays. So today we are going to continue our discussion about dilation, and we are going to look at several different examples to emphasize our understanding of this topic. So in previous lesson we mentioned in dilation we always discuss center of dilation is where do we start, where do we look at the relation between the images and pre-image, and also scale factor is one, is more like a ratio to talk about how big or how small the picture is going to be changed. So let's check several different examples here to understand this term here, scale factor. So let's check the first example. The first example, we don't have the picture, but we do have the description. So after dilation with the center 0, 0, the image dB, so this is like a segment, is d prime, b prime, and we know the length of the both one, so they are asking what is the scale factor. As we mentioned before, when we talk about the scale factor, is so scale factor, we oftentimes we just use K to represent this ratio, is image over pre-image. In this case, we know the image is d prime, b prime, and this is dB. So all we need to do is just plug into length of each one and we can figure out the answer. So this answer will be 4. You can use calculator or you can use mental math, you will get the answer. So this is the scale factor of this, and this is pretty straightforward. So basically you can just imagine this graph, probably this is 4.5, this is dB, and then this is gonna be like a very long one for d prime, b prime, and the ratio is always coming from the scale factor is always we use image over pre-image, which is to determine what is how big or how small. And clearly it is a, so some students probably understand this or recall this is the enlargement because it's getting bigger. Okay, so now let's check the different example here. So this one, we are going to dilate this segment about point P. So in this case, this is the center of dilation, and also scale factor is 3. So before we start, one thing I just want to remind you is try to focus on the analysis after we do this. If you do not understand the process when I do the dilation, is perfectly fine, because in the future we are going to discuss more examples about this. So in the first time, if you do not understand, which is perfectly fine. And also another way, just let you understand the center of dilation here. So center of dilation, my understanding is more like you can imagine this is, for example, this is, we have a flashlight here, and we are shedding the light here. So if you have flashlight hold at the location P, then the image of AB is more like a shadow of this one. So that's why we know the shadow is gonna around here. And we just need to know, we just need to be more precise about, since it's scale factor 3, then how do we describe it? So let's check this. So the way we do this is more like we move from the center to A, we move center from B, and we just repeat 3 times. So let's check, how do I move from P to A? So up to 1. So I'm going to repeat this. Up to left 1. So that's how do I move from P to A. This is the first time. So since it's scale factor 3, so I'm going to repeat this 2 more times. So this is the first time, up to left 1. So that's 1 time. Up to left 1, second time. Up to left 1, third time. So this is A prime. Again, if you do not understand this process, it's perfectly fine, because in the future we are going to practice exactly example again. So P to B is write 3 spaces, 1, 2, 3. So that's one movement. Move 3 spaces to the right. That's one movement. 1, 2, 3. This is second movement. 1, 2, 3. This is the third movement. So to avoid misunderstanding, I'm going to erase this one. Do not confuse yourself. And then we just need to connect them. See, everything use, this one can be much more easier. I'm going to use a bold one so it's easy for you to see. Okay, now I have a image is A prime, B prime. So what's a funny thing here is I'm going to, so let's check. The first thing is we know AB is like you move up the whole AB, sliding the whole AB to the top one. So you can see AB is parallel to A prime, B prime. So that's one thing, right? These two segments parallel. Another funny thing is we know the scale factor 3, so apparently, so A, B, A prime, B prime over AB is going to be 3 because this is a ratio, this is a scale factor between image and pre-image. That means A prime, B prime is 3 times of AB. So that's how long for A prime, B prime. So that's a several thing. And another interesting I want to show you here is if, let's connect to the B prime here. Maybe I use a different color so it's more easy to see. Let's use red. You see, once I connect everything here, we actually have two triangle PAB and triangle PA prime B prime. And clearly based on what we said, the dilation is going to create images and pre-image. They are having the same shape but different size. So that means these two triangles are similar. So that's why I put dilation in the same unit in similarity, because this is exactly how related they are. Dilation will give us similar pictures. That's what we mentioned before. So now it's more like everything come together, right? So this is one thing. After we do this, I just wanna you pay attention. These are the facts we mentioned. 1, 2, 3, 4, but this is all related. So this analysis I want you to focus on more, and that's why you can connect all the images, all the pre-concept together to truly understand what dilation is. Okay, last example will be finished. So as this one, as you mentioned, this is more like, this is where do we hold the flashlight. So whenever you think about this, it's always, think about this is a flashlight. We are shedding the light from here. And then this says, this one can be a little bit tricky because this says CD is the image of this. So it's like a backwards. So this is pre-image and this is image. And also this said, what ratio is equal to the scale factor K? So as we mentioned, K, which is scale factor, is always image over pre-image. So that's why it clearly is going to be a CD, CD over AB, right? But we don't see anything from the choices. So we are going to extend our understanding to, let's see what happened to these triangles. I'm going to connect these two. Okay, so CD over AB is more like a smaller triangle. I'm going to draw this smaller triangle here. So it's going to be, this is EDC. So a smaller triangle. CD over AB is a smaller triangle over a bigger triangle. So that's why we can look for which one is actually represents smaller triangle to bigger triangle. So the first one is EC over EA. So clearly, this is our smaller triangle to bigger triangle. So that's why it's going to be 1. So that's what I mentioned before. Sometimes when we look at the problems, you have to extend it, your understanding to a different perspective, not just on whatever you see from the picture. You can definitely create more ideas here. And also, if you just choose, let's just check another choices to see why this is wrong. Let's see, this is say EA over BA. So EA is the bigger triangle this side, BA is the bigger side of the side of the bigger triangle. So if we put the ratio between these two, it doesn't make any sense, right? So that's why this is this one. Okay, I'm sorry it's like taking long to like share more examples, but I really want to show you this example to help you to truly understand what's the situation here, so you can have better understanding of dilation and make a connection between dilation to similarity. This will be the lesson. This will be the last lesson before the break. I hope you can truly just watch that and understand the relation between dilation and the similarity. And also, I hope you all have a very, very happy holidays. See you soon, everyone.